Way number 20 deals with subatomic particles. And the way you remember subatomic particles is the acronym PEN, P-E-N, protons, electrons, and neutrons. If you ever need to look up the charges of these particles, we always can use table O to indicate the charge of each of these particles. This is indicated by the subscript or bottom number for each of these particles. So PEN, protons, P have a positive 1 charge because the subscript has a positive 1. Neutrons have a 0 charge because the subscript is 0, and electrons, which are also called beta particles and are indicated by this E symbol, have a negative 1 charge. So for problems involving the charges of atoms, we'll only have to look at the atoms that have charge, which are protons and the electrons. So to apply this principle, let's try some problems that involve charges. An ion that consists of 7 protons, 9 neutrons, and 10 electrons has a net charge of for this problem, we care nothing about the neutrons because they have a neutral charge. Table O tells us that protons have a positive 1 charge and electrons have a negative 1 charge. So positive 7 plus a negative 10 will get you a total charge of negative 3. The number of electrons exceeds the number of protons, so the overall charge of this ion should be negative. Let's try another problem. Which statement describes the charge of an electron and the charge of a proton? Once again, to look up charges, you can always use table O. Go ahead and look at that and see if you can figure out the answer. Okay, an electron has a charge of negative 1. Beta particles have a charge of negative 1, and protons have a charge of positive 1. These are indicated by the bottom number subscript on table O. Next problem. Which phrase describes the charge and mass of a neutron? Okay, we haven't quite gone over mass yet, but mass is indicated by the top number, the superscript. But you know that the charge of a neutron is neutral because it has 0 as its subscript. Therefore, the correct answer has to be 4. No charge, and the mass indicated by the top number on table O is 1. Therefore, it has a mass of 1 AMU, 1 atomic mass unit. So the answer is 4. You should have been able to eliminate 1 and 2 because neutrons are neutral. One fission reaction for U-235 is represented by the balanced nuclear equation below. Uranium-235 plus 1 neutron gives you xenon-140 plus strontium-94 plus 2 neutrons. Both radioisotopes produced by this fission reaction undergo beta decay. The half-life of xenon-140 is 13.6 seconds, and the half-life of strontium-94 is 1.25 minutes. On the diagram below, draw an arrow to represent the path of an emitted beta particle in the electric field between 2 oppositely charged metal plates. So really, you only have to use this information and the fact that we have a beta particle here to indicate the pathway that this beta particle will go. So see if you can predict what the pathway of that particle will be. Okay, given that beta particles have a negative charge, we know that opposites attract. A negative beta particle will always tend toward the positively charged plate because opposite charges will attract. Therefore, you should have drawn something that looks like this. Next problem. Which subatomic particles are paired with their charges? Once again, use table O. This problem becomes very simple. Electrons are negative. They have a negative 1 charge. Neutrons are 0. They have a 0 charge. And protons have a positive 1 charge. So the only possible answer is answer choice 2. Last problem. Compared to an electron, which particle has a charge that is equal in magnitude but opposite in sign? Don't be confused by the word magnitude. Magnitude just means value. So 1, 2, 3, 4, 5, whatever. And it's asking for which particle has a charge that is equal in value to an electron, but opposite in sign. So we need to know what the charge of an electron is in order to answer this problem. Think about what the answer is. Okay, we know that an electron is negative. It has a -1 charge, so the magnitude is 1, but its sign is negative. Therefore, we're looking for a particle whose charge is 1, but sign is positive. The only one that fits that criteria is answer choice 4, a proton. A proton has a +1 charge, an electron has a -1 charge. They are equal in magnitude. They both have a value of 1, but opposite charge. Hopefully this was helpful. Remember, problems involving charges of subatomic particles can always be looked up by the bottom number of table O. Protons, neutrons, and electrons, sometimes called beta particles. Hopefully this was helpful, and thank you for watching.